What's up, guys? Back here with another video, and today I am doing a part two to the gradient descent video I did earlier. Now, in that video, we only looked at one variable. It was single variable regression. So we had the price. All we looked at was price. We were predicting price, and only thing we looked at to predict price was the square footage of the house. But in the real world, we wouldn't really do that. I mean, look, we have all of these features, all of this data. Why would we only look at one feature? Because we know there's tons of features that would go into it. So I'm going to show you kind of like just giving a little understanding of how you would implement gradient descent with if there was more than one X, like if there was more than one feature you're looking at. By the way, feature, variable, and I believe even factor and X variable are all used interchangeably, just to clarify. So basically, right here, when calculating the error, you predict the value, and then you take the difference between that prediction and the actual value. So let's say our formula tells us that the house is $500,000, but the house is actually $570,000. Then 70,000 is our error, and we use the mx plus b formula in regression cases to calculate this. So with this single variable, we only use mx plus b. It is that simple. You've probably seen this. I know they taught me this in 7th grade. So probably anywhere between 6th and 8th grade is when you probably saw this. But now for a multivariate regression, it's the same exact thing, except you have multiple m values and multiple x values. And you take the m1 times x1, and then you add m2 times x2, and you do that for all of the m and x variables that you have. The m variable is the slope, so for every feature you look at, you have an m value. So in our example, this new example, we're using two x values. We have our first x value is the square footage of the house. Our second x value is how many years old the house is, which I used lambda to basically a lambda function right here. If you look at this line of code, to basically calculate how old each house is by taking our year 2021 and subtracting the year that the house was built. And I used a lambda function because it's much faster than the alternative, which would have been a for loop. Now, moving forward, so we're calculating error with our m2 or our two m values and our two x values. Two m values, two x values, just making sure I said that right. And then we take our step, and because we have two m values, we will have two derivatives down here. So basically all you have to do is, originally we had deriv m is equal to x of I times y of I minus m times x plus b. Like I said, the difference now is it's m1 is x1 with m1 times x1 right here. And then if there were three m's and three x's, like if we had three features that we were looking at, there would be another line of code inserted right here, except all the twos here would be turned to threes. So it would be deriv m3 is equal to -2 divided by n times x3 of I, and so on. I hope this makes sense here. And then gradient descent. And also I'd like to add that the functions are going to now take in multiple x values and multiple m values. So when you make these functions, they kind of have to be preset to take in a certain amount of of features. So there we go. And then there's also, when you're storing the results, we have two slopes, because an m value for every x value, we have two x values, and slope is the m value. And then this error, I stopped this code because it was just taking a long time to run, but it does work. And basically that's the difference. So it's basically you're taking the m and x. For every m and x value you have, you take m times x, like m of 1 times x of 1, m2 times x2, etc. when calculating error. And then when calculating the step, you have them vertically. So you have the first derivative that goes with m1 and x1, then the second derivative that goes with m2 and x2, and so on in the code. So I hope that made sense. I'm trying something new where I'm trying to make like faster paced, quicker explanation videos. So I'm would like to know, like, if this video still makes sense at the much faster pace that I covered the topics. That would be great feedback. And just leave a like, comment, and subscribe, and I'll see you in the next one.